Module 6, 6.2C lesson. We're solving scale drawing problems and creating a scale drawing. So the word scale, defined. Scale indicates the proportion between the representation, which is a model or a drawing, and what it represents actually. Okay, the symbolic representation, let me give you an example first. So a map. A map has a scale of 1 inch to 250 miles, okay? And some of you may have seen a paper map before. Some of you have a GPS system in the car on your phone. And obviously the scaled down version of that GPS system or the paper map is not actually what the distance is. So there is a scale that stays consistent throughout the entire map that you're viewing. Okay, so 1 inch represents 250 miles. Okay, please notice the units that are key here. Okay, you cannot just say 1:250. Okay, that's not an accurate statement. Okay, 1 inch represents 250 miles. That's a very different statement than what I just said without the units. All right, number 1, the scale of a map is 1 inch to 44 miles. About how far from Sacramento is Santa Rosa if the map distance measures 1.5 inches? Okay, you do not need to worry about converting inches to miles and being in the same units or miles to inches, okay? Setting up a proportion with the scale takes care of that for us. So let me demonstrate that. Sometimes it's really helpful to write the way that you're going to set up the problem. So anything to do with inches for me is on the top. Anything for miles for me is on the bottom. Okay, you could have set it up the other way, miles over inches, and anything for you would have been miles on the top, and then any inches would have been on the bottom for you. Okay, so I've got, this is key to our problem. That is the scale that's given to us. So we've got 1 inch to 44 miles. Do not put the units within the proportion. Okay, and that I'm going to set equal to, they tell us the map distance measures 1.5 inches. Okay, so you could have said map over actual if you wanted to say it in those words. Okay, but 1.5 inches is going to go on the top because that's where my inches are. And then X is our unknown. Okay, so when I cross multiply like I learned last module, I get 1x equals 66. So the distance, I'm going to put the actual distance, is about 66 miles. That's our answer, and that's our work in solving that. All right, your sister wants a large poster version of a small drawing she made. She drew it on centimeter graph paper. What are the dimensions of her original grid as shown to the right? Okay, so you're not looking for the size of this little picture. You're looking for the size of the grid. Okay, so if these are centimeters, 1, 2, 3, 4, 5, 6, 7, 8. So this is 8 centimeters here. 1, 2, 3, 4, 5, 6, and this is 6 centimeters on that side. So I'm going to put 8 centimeters by 6 centimeters. She wants the poster version to have a height of 2 feet. What scale in simplest form should she use so that her poster is 2 feet tall? All right, so height of original. Height of original, we are going to do 6 centimeters. I'm going to take the 6 centimeters here, the height. 6 centimeters. Okay, and they want a height of 2 feet. Okay, and then the height of the large poster, then, the height of the large poster in simplest form. Okay, I'm going to go ahead and I'm going to pull a 2 out of these two. So 3 centimeters will go with 1 foot. Okay, so that's the scale. This is the scale. This is the scale in simplest form. Okay. All right, the side of a square on the grid in the original picture is 1 centimeter long. How long will the side of a square on the grid be in the final poster? All right, so I'm going to have centimeters on the picture over feet in real life. Okay, so I'm going to be using this simplest scale. Okay, so I've got 3 centimeters to 1 foot equals, okay, I need 1 centimeter put in here over, we don't know. Okay, so let's solve this. We've got 3x equal 1. Oops. 3x equal 1, and then I'm going to divide by 3, and I've got x equal 1/3. Kind of running out of space here. Let me scooch it over a hair. X equal 1/3. So it will be 1/3. Now 1/3's units are feet. It'll be 1/3 foot. How many inches? Some of you may answer in inches. How many inches is 1/3 of a foot? Well, there are 12 inches in a foot. So if we do 1/3 times 12, 1/3 of 12, that would be 4. Okay, so you could say either one of those. It doesn't say how long will it be in inches or how long will it be in feet. So either one of those would work. All right, what will the dimensions of the final poster? What will be the dimensions of the final poster? All right, so we're going to take this, this 8. Okay, so here we go. We've got centimeters over feet. We've got this relationship 3/1. Okay, and then we've got this 8 centimeters. This 8 centimeters that we need to convert into how many feet? So this would be 3x equal 8. Divide by 3. 8/3. Okay, so 8/3 is the length here that it would need to be. Okay, and then let's go ahead and find 6. Okay, 6 centimeters. So centimeters over feet. Not need to do this because they gave us the 2 feet tall back here. Okay, they gave us the 2 feet tall. So we just had to find out this down here, this 8/3 for this distance. Okay. If you got it in inches, or so 8/3 times 12 would be 32 inches by, and we're going to go ahead and multiply this 2 by 12, 24 inches. All right. Next page. All right, Hal used the scale 1 inch equals 6 feet for his scale model of the new school building. The actual dimensions of the building are 30 feet height by 120 feet width by 180 feet length. What are the dimensions of his scale model? All right, so here's the scoop here. So we're going to use this 1 inch. This is key right here. Okay, so we're going to have the scale model over actual. And if you want to write model over actual instead of inches over feet, that's fine too. All right, so everything with inches is on top, so I'm going to use 1, and everything with feet is on bottom. And I'm trying to find out the height. So let me put height right here. I'll put that in pink. This is going to be the height. So I'm going to put 30 right here. So that's going to be 6x equal 30. And if I divide by 6, I'm just kind of tight on space. So I can probably tuck that in there. Divide by 6, and I cross multiply. Okay, so that's the height. All right, the width. The width is going to be the same 1 over 6, but this time I'm going to put a y in there, and I'm going to put 120 down here. All right, so I've got 6y equal 120. 6y equal 120, divide by 6, and I end up with y equal 20. Okay, let's look at the length now. I still use my 1/6. And this time for the length, I've got 180 to convert here, and I'm going to use a z. So I've got 6z equal 180. Divide by 6. So z is 30. Okay, now remember all these values are in inches because those were all of our unknowns on the top, which went with inches. So the scale model is 5 inches by 20 inches by 30 inches. That's your answer. Okay. Number 4, Ellie was drawing a map of her hometown using a scale of 1 centimeter to 8 meters. Again, let me highlight that. The actual distance between the post office and City Hall is 30 meters. What is the exact distance between those two places on her map? All right, so they're talking about this is what it really is, 30 meters, and we're asked to find out how much on the map. Okay, so I'm going to do centimeters over meters. It's important to understand centimeters is the map, meters is the actual. So if you want to put map over actual, that's fine too. All right, so we've got this 1 over 8, 1 centimeter to 8 meters. And then that is equal to, okay, and we do not need the same units when we're finding these values of the map size versus the actual size, okay? The proportion kind of takes care of that relationship of it in itself. All right, we got 1 to 8 and then 30 meters. So we better put 30 on the bottom. So we've got 8x equal 30. 8x equal 30. And when we divide by 8, we would have 3.75. Okay, so the exact distance on the map is 3.75 centimeters. In her drawing, the distance from the post office to the library is 22 centimeters. What is the actual distance? Okay, this time we're given a map measurement and we're asked how far in meters it really is. So again, I'm going to use the centimeters over meters. I've got my 1/8 centimeters. I'm given 22 centimeters and I'm asked how far is that in real life. So I've got 1y equals 176. The actual distance is 176 meters. Okay. Alan made a scale drawing of his rectangular classroom. He used a scale 1/2 inch equal 4 feet. His actual classroom is 32 feet by 28 feet. What are the dimensions of a scale drawing? Okay, we are given both of these measurements in feet, so we have two problems to solve in this part A. Okay, we have to find what 32 feet is in inches, and then separately we have to find out what 28 feet is in inches using this scale. We're not converting inches and feet with there are 12 inches per 1 foot. Okay, that's real life, but this is what it is as a scaled map or a scaled drawing. Okay, think of an architect. An architect has pages in front of them. They're pretty big, but they're not the size of the house or the building they're building. Okay, all right, so I'm going to do inches over feet. And I'm going to have 1/2 over 4 equals 32 feet. That better be on the bottom. Okay, so I've got 4x equals 16. And I'm going to write that up over here. There's not enough space. 4x equals 16. Divide by 4. And you get x is 4. Okay, now this guy, let me draw kind of a line here. I'm going to have inches over feet again. Same scale, 1/2 inch goes with 4 feet. But this time I want 28 feet. So 4y equals 14. And I'm going to write that up over here. 4y equals 14. Divide by 4. Okay, and I get y equals 7/2, or 3 1/2. Okay, so I got to write this kind of small. His scale drawing is, okay, and I need to stay in this order. 4 inches by, and then this guy came out to be 3 1/2 inches. That's my answer. Okay. All right. What is the scale factor? Okay, now here is a trick that's super important. When you're talking scale factor, not scale, when you're talking scale factor, you need to be in the same units. You need to be in the same units. Okay, so they want the scale factor from the classroom to the drawing. Do you understand this is going to be smaller than 1 because we're shrinking the real classroom to the drawing? We're shrinking. Okay, so let's think about this. If 4 feet, I don't know why I wrote a capital, 4 feet equals 1/2 inch, doesn't it make sense that 48 inches equals 1/2 inch? Okay, aren't there 12 inches? 12 inches in a foot. And if we have 4 feet, 4 times 12 is 48 inches. You know, I want a 1 here. That would be 96 inches to 1 inch. Okay, so I'm either going to be using 96 over 1 or 1 over 96. And we already talked about we're shrinking. We're going from the real thing to the drawing, so it has to be smaller than 1. The scale factor is 1/96 from the actual classroom to the drawing. Okay, what is the scale factor from the drawing, so small, to big? Okay, so we're just going to flip this 1/96 over. The scale factor is 96 from the drawing of the classroom to the actual classroom. All right. What is the mathematical relationship between the scale factor for lengths and the scale factor for areas? Okay, we've got to remember about this. Okay, the scale factor of the lengths has to be squared to get the scale factor of the areas. Okay, the scale factor of the areas of 2 objects is the square of the length scale factor. Okay, we talked about that a couple lessons ago. All righty, last page. Couple of true false and a little drawing to do. Audrey wants to make a scale drawing of the stamp below. She makes a scale drawing where 1 centimeter in the drawing represents 3 centimeters on the stamp. Which of the following are true? The drawing will be 1/3 as wide as the stamp. Okay, that's true. The stamp will be 3 times as tall as the drawing. That's true. The area of the stamp will be 3 times as large as the drawing. Nope, because you've got 3 times bigger on a drawing or on the actual and 3 times drawing on the actual. That's a scale factor of 9 for the area. False. It will be 9 times. The area of the stamp will be 6 times as large as the drawing. False. So it's not 3 times 2, it's 3 times 3. It will be 9 times. The area of the stamp will be 9 times as large. True. Okay, the scale of the drawing below is 1 unit equal 1/4 foot. Use the grid below to draw a new scale drawing where 1 unit is 1/2 foot. Okay, I kind of wish that 1 came down here. This means that the scale factor from the original drawing to the new drawing is, okay, so let's think about that. If 1 unit here, it represents a 1/4 foot, and now it's going to represent a 1/2 foot. Okay, the scale factor from the old one to the new one is going to be, is this going to be a bigger or smaller? Let's think about this for a minute. So this is 1 unit is a 1/4 foot. And then if we have 1 unit representing 1/2 of a foot, it's going to get smaller. So it has to be smaller than 1. Okay, so everything that you see here needs to be halved. Okay, so this 4, 1, 2, let's start here. 1, 2, 3, that would be 1.5. Okay, this guy here, 1, 2, 3, that would be 1.5. 1.5. This right here would be 1/2. This right here would be 1.5. This right here would be 1.5. This right here would be 1. This right here would be 2. 1, 2. This right here would be 1.5. 1.5. This right here would be 1. This right here would be 1. 1, 2, 3. Oops, I went too far. Sorry, that's 3, but that needed to be 1.5. 1.5. Okay, that shouldn't be there. This needs to be 1/2. And then this needs to be 1. Okay, hold on. That needs to be 1. And then it needs to come down. Let's make sure we're getting back to the beginning. 1, 2, 3, 4, 5, 6, 3 units. 1, 2, 3. Okay. Okay, and then the little eyeballs and the little nose. Okay, so this is 1 unit in, so it needs to be 1/2 a unit in. And it's 1 unit up, so it needs to be 1/2 a unit up. So everything's like 1/2, 1/2, 1/2. And then this is 1 unit in. Let's see where we are here. Let me see how many we are down. So down, it needs to come down 1/2 and over 1/2. So right here and then down 1/2. And then this one's over here. Okay, that was a little tricky. All right, that concludes, guys, our lesson for this.